this is Britt Caswell with another example video. In today's video, I'm covering example 1 from lesson 8-5 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to determine which type of function represents data. Alright, so we're going to be looking at tables of data and figuring out whether we should use a linear function, a quadratic function, or an exponential function in order to model that data or to create some kind of curve to fit it. So the first thing is looking for a linear function. And so what we have here is we have a table of values where they figured out what are called the first differences. So the first differences means that they just subtract the values of the y's. So 1 minus -1. 3 minus 1, 5 minus 3. Alright, so these are called the first differences. So if you subtract and the value is the same for every single hop, that means that you want to model this with a linear function. Alright, this would graph in some kind of straight line. Now, not all data graphs nicely with straight lines. Alright, so now let's look at how to test for a quadratic function. So on this one, what they did was they found the first differences, and they noticed that they weren't the same. So because those first differences weren't the same, that's what tells you that this part is not linear. I'm going to go ahead and put that note here. So not linear, and again, that's because these are different values. So then we analyze what's called the second difference. So to get a second difference, what you do is you take the first differences and you subtract them, just like we did up here. So 10 minus 6 was 4. 4 minus 10, 14 minus 10, 4. 18 minus 14, 4. So here, because the second differences are constant, that tells you that this should be modeled with a quadratic. Now, a quadratic, remember, is some kind of parabola. So this one's going to make a linear function. This one makes a quadratic. Now, we get all hyped up about checking for linear versus quadratic that we often forget whether we should check for exponentials. So remember, what we're going to do is we're going to test our first differences. All right, so they subtracted each of our y values. And then they went through and they tested our second differences, and those weren't the same either. So because the first and second differences weren't the same, they kind of changed tactics here. And what they did was they checked their ratios. So they did 2 divided by 1 instead of subtracting, 4 divided by 2, 8 divided by 4. And you guys know that if this hop is multiplication or division, that you're going to have an exponential function. And so this one is best modeled by an exponential curve. Now, if we were to plot these points, sometimes you can see when it would make a nice parabola or when it would make a nice line. But sometimes when you plot the points, it might only show half of the parabola. And so you might get like a quadratic curve and think that it's half of a parabola, or you might think that you might get half of a parabola and think it's a quadratic curve. So that's why you want to check these differences just to make sure. Sorry, differences versus ratio, I should say. So let's go ahead and let's try this. All right, so the first thing I'm going to do is I'm going to calculate my first differences. All right, remember the first difference is seeing if it's going to make a linear model. So -5 minus -2, that is -3. -14 minus -5 is -9. -29 minus -14 is -15. And -50 minus -29 is -31. All right, so because that first difference is not the same, that tells me that this would not be a good linear model. Oh, I'm sorry, that should have been negative 21, not 31. Make sure to subtract properly or you're going to mess yourself up. So since the first model didn't work with my first difference, I'm going to now try my second differences and see if this should be modeled with a quadratic. Okay? So negative 9 minus 3 minus negative 3 is negative 6. Negative 15 minus negative 9, negative 6. Negative 21 minus negative 15 is negative 6. So I'll even type it out here, work on my handwriting a little bit. So because the second difference was constant for these values, we would model this data with a quadratic function. All right, so we're going to go ahead and do that same thing now with part B. I'm also opening up my calculator because some of those numbers are a little large. All right, so first let's try the first difference. Okay. So 12 minus 4 is 8. 36 minus 12 is 24. 108 minus 36 is 72. And 324 minus 108 is 216. So because that first difference isn't constant, this is not a linear function. So now I'm going to go ahead and I'm going to check for the second difference. All right, so 24 minus 8 is 16. 72 minus 24 is 48. And 216 minus 72 is 144. So because the second difference does not work, this is not quadratic either. All right, so our first difference didn't work, our second difference didn't work. So now we're going to check for exponential. And so now we're going to do our common ratio. So 12 divided by 4 is 3. 36 divided by 12, 3. 108 divided by 36 is 3, and 324 divided by 108 is 3. All right, so this was checking the constant ratio. And so, ratio, not ratior. So because that ratio was constant, this model is best, modeled with a exponential. So because our values had a constant ratio, this data would be best modeled with an exponential. So there we have it, guys. That is how we determine which type of function best represents a set of data. Until next time.